Okay, so today we're looking at stationary points. So our learning intention is to gain the knowledge of the different types of stationary points. So we'll be successful if we can identify the local maximum or minimum stationary points, the global maximum or minimum, or any points of inflection. Okay. From the NESA Mathematics Advanced Glossary, if we have a point, this point will be a local maximum of the function if the function is going to be less than that point for all values of x near that point. We say that this point is a global maximum of the function if the function is less than that point for all values of x in the domain of x. Okay. Alternatively, obviously, if we have the local minimum, it's the same kind of structure, but we're looking for when the function is greater than that point. So basically, we can have turning points where this will be a maximum turning point or a minimum turning point. That will be a local maximum point because there's a point that's less than that, right? And that will be global. So the high extremes are your global and your in-betweens are your locals. Okay. So we can also get a point of inflection. This is when a point of inflection is a point on a curve where the tangent exists and crosses the curve, right? So these are all tangents, and we get a stationary point where the tangent actually sits and crosses the curve. Within the course of Mathematics Advanced, points of inflection can be found by taking the zeros of the second derivative and checking whether the concavity around those points changes. Okay, and that's from our glossary. So let's do some examples. We want to find the stationary point on the curve of y equals x to the power 4 minus 2 and determine its type. So the first thing I want to do is I want to find the first derivative. So the first derivative will be 4x cubed. Okay. And then we want to figure out, find the stationary points. Now that's going to happen when the first derivative is 0. So if that was the case, we get 4x cubed equal to 0. So x has to equal to 0. Okay. Then we want to test points on either side of your stationary points. Okay, so if my stationary point is 0, x equals 0, so I could do negative 1 and 1. And what I'm going to do is I'm going to plug it in to my first derivative. Alright, so when x equals negative 1, I'll get a negative number. And when x equals 1, I'll get a positive number. Okay, so it's going, so basically we've got a gradient going down, we get to a stationary point, and then we're increasing. So when x equals 0, we get a local minimum turning point. It could also possibly be the global turning point, but we definitely get a minimum turning point. So you can ignore the local global for this stage because we don't have a set domain. The 4 is state the type of stationary point. Okay, so we're going to follow the same steps for these examples we're going to write. So the first derivative of this would be negative 2 4 minus x to the power of 1. Okay, we want this, let y dash equal to 0, so we get so 4 minus x equals 0, so x equals to 4. All right. We're going to test each points on either side of it using our first derivative. When we plug into 3 into the first derivative, we get a negative number. When we plug in 5, we get a positive number. So once again, we get something that looks like that, decreases stationary point. Yep. So this is, so when x equals 4, a minimum turning point occurs. All right. So if we have this cubic, it has 2 stationary points. We want to find the coordinates. Okay. So the first thing we're going to do is differentiate. Okay, we're going to, which is also the same as factorizing that difference of 2 squares. So that's the first derivative, right? So stationary points occur at x equals 1 and negative 1. Okay. All right. So when x equals 1, y would equal 1 minus 3 plus 2. Okay, that's the first point. And when x equals negative 1, so negative 1 plus 3 plus 2, so negative 1, we get y equals 4. Okay, so they're the coordinates. Okay, now we want to determine the nature. Okay. I'm just going to do it underneath here. And then we're just going to test the points. So 1, that's stationary. Using the derivative, so it's negative. That's going to be 12 minus 3 is positive. Yep, so this is going to be a minimum turning point. So we've got negative 1, negative 2, and 0. So we know we get 0. So if I put negative 2, that's positive. We end up positive, so we get like that. So we get a maximum turning point here. So when at the point of 1, 0, we get a minimum turning point, and at the point of negative 1, 4, we get a maximum turning point. Okay.